To infinity and beyond is a phrase commonly heard by the world's best superheroes. But what does that really mean? If asked what infinity is, a child may say that infinity is the biggest number to ever exist and draw this sign. So what if I ask this same child what they think that biggest number is? Here we run into a problem. It is very difficult to think of infinity as a number because infinity mostly does not behave like other numbers. Say we have a stopwatch set to 30 seconds. We know that there are half as many on seconds as the total number of all 30 seconds. Now, let's just let the stopwatch run. If we let the stopwatch run forever, there would be an infinite number of seconds. Now, there is an unending number of seconds and an unending number of even seconds. Thus, it is no longer true that there are half as many even seconds as the total number of seconds. They are both infinite. Although there is a set of rules involving basic operations with infinity, in some cases we do run into significant issues because it is not clear which infinity is bigger. This brings us to another key concept to understanding infinity. There are infinities of different sizes. Let's go back to the infinitely running stopwatch. Whether we wanted to count the even, odd, or total number of seconds on this stopwatch, it would always result in what is classified as a countable infinity. But now let's say we exchanged our old stopwatch for a new one with infinite decimal places. This way, we should hopefully be able to get the exact number of real numbers between 0 and 1 second. Unfortunately, we wouldn't even have a place to start counting, as you can always add another decimal. This is classified as an uncountable infinity. We also know that an uncountable infinity is greater than a countable infinity. So why do we care about understanding infinity? Our universe is expanding. Will it expand forever into infinity? What if the universe does expand into infinity? Here, we run into some problems. In every corner of science, we make predictions. Now, with normal probability, we use equations with rational numbers, 1, 2, 3. In an infinitely inflating universe, calculating probabilities for different events often yield tricky results, such as our old enemy, infinity divided by infinity. So for our purposes, let's say that the universe is spatially finite. This takes us back to our initial phrase, to infinity and beyond, where the concept of infinity helps us grasp what is actually beyond our universe. First, we will have to make it clear that just because the universe is spatially finite, it does not mean that there's any beyond. This can be a complicated idea when thinking of the universe as being in 2D. A flat sheet of paper will have edges. Why doesn't our finite universe? Think of our universe as the surface of a spotted balloon, and the galaxy as we know and love as those spots. As the balloon is blown up, it mimics the expanding universe, and each spot, or galaxy, is moving farther apart from each other. Even in our finite universe, infinity still comes into play. Though the size of our universe may be fundamentally finite, from our perspective, the universe is infinite. Say we wanted to leave our spot on the surface of the balloon. Because the balloon is rounded, we can travel and travel, never reaching an end. Thus, in our universe with no edges, beloved superheroes may be wrong in saying to infinity and beyond.